Okay, so in this video, we're going to look at the product rule for differentiation. So let's look at something like this function f of x. It's a product of two functions, one's quadratic and one's linear, but we can simply just multiply this out, just expanding it. And if you were to do it, multiply each part by the other, you would end up getting x squared times 2x. That's 2x cubed. The outer term would be minus x squared. The inner term would be 6x squared. And then finally minus 3x, which simplifies to this thing down here. Now that wasn't so bad at all. And we can differentiate this term by term using our power rule. And we would get this equation right here. So that was fairly easy to do. But there are definitely products that would be a lot harder to find. Consider this one here. If we've got 4x minus 3 to the third power and then x minus 1 to the fourth power, and we want to multiply those two together, if you want, you can take the next 20 minutes of your life to do that, or you can take the next 30 seconds of your life and learn this product rule, which is really powerful. And I'll just summarize it here. So if y is a function in terms of x that can be expressed as the product of two functions, we're going to call them u and v for our notation here. So anytime you see a function that looks like just two functions that we can differentiate being multiplied together, we can rewrite it as really the derivative of u times v, the two functions. That's going to be equal, this is the product rule, the function u times the derivative dv dx, the derivative of the function v with respect to x, plus the function v times the derivative of the function u. So it's actually kind of a interesting symmetrical looking formula and easy to remember. Or if you prefer using function notation, we can think of it as if we name one of the functions f of x and then the other function g of x, then the derivative of the product of those two is given by f of x times g dash x plus g dash x times, or g of x times f dash x. So it's literally, if you have the two functions, it's the sum of one function times the derivative of the other plus the other function times the derivative of the first one. So it's fairly easy to remember and fairly easy to do. It's really no more work or computation than the chain rule is. So that's that, and next let's mention Leibniz. This is just kind of a quick note about Leibniz, who was a German philosopher, mathematician, scientist, and he developed this this notation for dy dx. Remember, we talk about a derivative as a rate of change of one variable with respect to the other, and so he was pretty important in developing that. All right, moving on to some examples.